Here comes an exploratory factor analysis video in SPSS, okay, also called EFA. What I figured I'd show you is the vocabulary here in this preview to the movie here. There's several new words that you need to memorize so you can connect your declarative knowledge with your procedural knowledge. There's your college education for you. But here's the vocabulary words that we're going to go over in this video in no particular order. And here they are in alphabetical order. So you can pause this if you want. Dun, 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 dun. But on with the show. Welcome to Exploratory Factor Analysis. We're going to put together this real quick video to show you how to run an exploratory factor analysis in SPSS. So we have a survey with 18 questions that are trying to measure depression. Okay, so that's what the data looks like. It's all ordinal. Let's take a look at the real data. It just looks like that. Okay, so, and then we have roughly a huge sample size of about 2,500 and above. But let's go ahead and run this now. First step is you're going to go to Analyze, Dimension Reduction, Factor. All right, descriptives. You want the coefficient, significance, determinant, and the Comeau and the Bartlett's. Extraction. We want the scree plot first. Remember, we're just doing a PCA now. Continue. No rotation, no scores, no options. Now you got to get all your variables over there and do them all at the same time. So, but everything's preset, so we're ready to click OK. Okay, so here is the output. But before we look at the output, we should probably look at the assumptions. Please hold. The assumptions of a factor analysis are sample size, and a general rule of thumb is anywhere between 5 to 10 participants per variable, which is per question. Okay, so we have 18 questions, but we got over 2,500 subjects, so that's not going to be an issue with our analysis here. Reliable correlations, we're going to look that up using the Bartlett's test of sphericity. Normality is not an issue here, right? It's not an assumption of EFA. And the last thing is multicollinearity. We will use the determinant of this matrix to see if it's multicollinearity or not. But let's get back to the output. First box. This is your R matrix box, or all the correlations between all of the items, two at a time. So there's your sample size measure, your KMO. That is perfectly fine. It's just got to be greater than 0.5. If it's less than 0.5, then you have a sample size issue. There's your test of sphericity from Bartlett. We want that to be significant, and it is. What this basically means is that you have at least one significant correlation between two of your items somewhere. Okay, so that's a minimum number, is you got to have at least one correlation in there somewhere before you can run an EFA. So here's our communalities, that's the right word, communalities?
That's the right word.
That's the right word. Box plus the extraction, the strength of the extraction. In other words, this question 1, 0.418. That means that question 1 loaded up whatever its new factor was at about 41.8% of the variance can be alluded to that first factor. So this extraction point, you're looking for any number that's less than 0.3. So if you have a number under the extraction table that's less than 0.3, you probably will have problems with that individual question or that item. And I don't see anything less than 0.3, so I think we're good to go. And here is our total variance explained. So according to this table, get back down there, we should have 1, 2, 3 new factors. Those are the factors that have an eigenvalue of greater than 1. You'll notice here once we hit the component 4, the eigenvalue drops down to less than 0.1. So it looks like we're going to keep 1, 2, 3. But we're going to double check. We're going to run a parallel analysis. Please hold. We have this web address on the page in the Moodle that says parallel analysis, so please use it. Okay, so this first box is asking us for the number of variables. That's the number of questions. So we got 18 questions. The second box is asking us for our sample size, and our sample size is huge. And we're going to click submit over here and wait for a response, please. So at the parallel analysis calculator page, this column where it says means, these are now eigenvalues. So you're going to keep the first root, the first factor, the first component, if this eigenvalue is less than your calculated eigenvalue. So we're going to keep the first factor because our calculated eigenvalue is 6.9, which is greater than 1.14. So there's factor 1. Factor 2, we're going to keep it because 1.3, the calculated eigenvalue, is greater than 1.1. So we're on our third factor. Shall we keep it or not? So theirs is 1.09, ours is 1.2. So we're going to keep the third factor. We're on a roll here. Will we keep number 4? Yes or no? Theirs is 1.07, ours is 0.976. So stop. We're not going to keep the fourth component. In fact, we're not going to keep anything past the third. So according to the parallel analysis, we should retain 3 new components or 3 new factors. So hold on. So now we know the correct number of new components to retain. So we're going to redo this bad boy. We're going to go back up to Analyze, Dimension Reduction, Factor. Let me move this over for you a little bit. We're going to go to Extraction. We're going to put it on a fixed number of just 3. All right, after we've picked the number of components that we're expecting, we're going to go into the rotation part. We're going to do the oblimine. Again, that's because there is a glitch in SPSS. This is the only way we can figure out a way that would generate the table we need to look at, and that is the factor correlation table or the component correlation matrix table, because that'll tell us whether our factors are going to be orthogonal or oblique. So we have to pick the oblique, which is oblimine. We're going to click Continue. Okay, you got to go to Options. We're going to sort them by size, and we're going to suppress them. We don't want any coefficient that's less than 0.4. Okay, so that's going to be our cutoff for the coefficients. We're going to click Continue, and I think we're okay to click OK. All right, so here is our new output part. Okay, here we go. So once we made those changes, we're just simply going to scroll down to the bottom of the output sheet. We're only looking for the the factor correlation or the component correlated matrix box to determine if our new factors are going to be orthogonal or oblique. So we're looking at these correlations, and my eyebrows are going way up. They're not close to 0, okay? So they're not weak, so they're moderate, but again, they're not greater than 0.5. They're close, but they're no cigar. So I'm going to go ahead and call this an orthogonal matrix. Again, I'll say that again. If these correlations here were all greater than 0.5, that means that your new factors are strongly correlated, and you should stick with the oblique rotation. But since they're not greater than 0.5, we're going to assume that they're orthogonally related. So we're going to redo this one last time and switch the rotation to, let me move this over here. What we're going to do is switch the rotation to a Varimax. Varimax is the orthogonal of choice. And click OK. And here's our new output. Let me shifty. So again, here's you're going to get a lot of repeated data from SPSS every time you go in and make any kind of changes. So correlation table, don't really need that. We already got that. We did that. We did that. Scree plot, we already have. Component matrix, right? How long they, how they load up. Actually, we don't even want that. We want the rotated. Here we go. This is our important box right here. Rotated component matrix. So this is going to tell us which question is under which factor. So according to this, question 1 has underneath it, factor 1, the new component, factor 1, has question 5, 16, 11, 6, 12, 8, 13. So those questions are strongly related. So whatever they're measuring must be relatively the same thing. The second factor, the second component, has these questions underneath it, 17, 18, 12, blah, 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 blah. And the last factor only has 3 questions underneath it, 7, 9, and 15. Okay, so we're good to go. The next step, you might want to write these down somewhere, which questions, which items load up under which of the factors, because we're going to use that data to run a reliability test on each of our factor. So give me a second and we'll get that going. All right, this is going to go fast. Checking the reliability of our new factors. You're going to go to Analyze. You're going to go to Scale. Reliability. Okay, we're going to pick the questions that loaded up under the first factor, factor number 1. And Copilot, please read them to me. 5, 6, 8, 11, 12, 13, 16. And that's it. You go to your statistics button. The important one right here is the scale if item deleted. In other words, if you don't reach the Cronbach's alpha, that's your measuring unit. We want a minimum of 0.7 on the Cronbach's alpha. If your Cronbach's alpha is less than 0.7, this scale if item deleted becomes a very important tool. It will tell you if your Cronbach's alpha will go up or down if you throw out a specific question. So you don't have to worry about that unless you have a low Cronbach's alpha. But let's see what we can do here. Let's click the Continue button. Click the OK button. And it should spit up a Cronbach's alpha box. And there it is right there. Bam. So the good news is that our first factor has a very strong Cronbach's alpha, which means it's highly reliable. And there's 7 questions that go into that first factor. So that was good for the first one. Let's do the second one. We're going to go to Analyze, Scale, Reliability. We're going to reset this. And I'm going to pause this while I put all the second set of questions in there. Please hold. Well, it wasn't as bad as I thought. Okay, statistics, scale if item deleted, click Continue. Okay, so our next factor number 2. Our Cronbach's alpha is plenty big, so it's greater than 0.7, so that's all we need to know, and it's got 3 questions underneath it. Looking good, looking sharp. So we're going to check the last one now. We're going to go to Scale, Reliability. We're going to reset our data. And through the magic of technology, I'm going to enter all the questions that load up under factor number 3 in a blink of an eye. Amazing, amazing. So these are the questions that load up under the third factor, statistics, scale if deleted, continue. Okay. All right, let's check out that. Oh, we got a problem, Houston. Cronbach's alpha is only 0.6. We have a problem. We want it to be at least 0.7. So that's when that item, if deleted box comes out, that's the one right underneath it. So let me pull this up a little bit. So according to this wonderful little box, oh, right there, if we got rid of question 2, our Cronbach's alpha for the new factor number 3 would jump up to 800, and that's what we were wanting. So that's what we would do. We would delete question number 2 from the survey. So in order to make this a more perfect survey, we would delete question 2 and drop down to 17 questions. So in a nutshell, what we have found out from this 18-question survey that's trying to measure depression, that it looks like it's measuring 3 unique dimensions of depression, such as maybe work-related depression, relationship-related depression, or maybe financial-related depression. So a very important last point here is you as the researcher, you got to go back and look at those questions that are under each of the new factor, and you have to read each question and try to decide what is exactly the common characteristic that each one of these questions is trying to measure. Okay, so after you read the questions, you should have what we call an umbrella term or something, whatever that specific thing is measuring. So that's up to you, the researcher. But that's it for now.
Like we're missing something.
Wait.
No.
MGZ and Copilot Out of here. Say something.
Don't say what.
I don't know. All right. So, all right.
Excuse me.
We're through.
Yeah. Bye.
Bye.